So previous class we were discussing about magnetic field due to current carrying elements. So here we have two laws. One is Biot-Savart law and Ampere-Circuital law. So in Biot-Savart law we have that formula that is not here. So we have integral dB is equal to, we have mu0 by 4 pi into I into dl cross r divided by r. This is the formula. In that we have, like for the current carrying loop, about that it is given. The second one is Ampere-Circuital law, solenoid and toroid. Ampere-Circuital law is closed integral v dot dl is equal to mu0 I. Now there are three cases in this. One is current carrying, straight current carrying wire. Second one is solenoid, and third one is toroid. So in the first one, what he says, when there is a wire which is carrying current, around it there is a magnetic field. Okay, this loop is said to be Amperian loop. Okay, that loop until what you want to take the magnetic field, that perimeter or that loop is known as Amperian loop. And the radius is what? Radius is r. I is the current, b is the magnetic field. So the formula is given here: closed integral v dot dl is equal to mu0 I. And here closed integral dl is nothing but L, which is equal to 2 pi r. 2 pi r is the perimeter of the circle of the loop. Okay, and what we are writing, v dot 2 pi r is equal to mu0 I. Cross multiply, you will get the answer. This is for a current carrying wire only. Okay, to find out the magnetic field. Second one, it is about the solenoid. This is a solenoid. It's a long helical wire. A long helical wire closely wounded. Is closely wounded, where length is much greater than the radius of the circle or radius of the loop. So, and they are enameled. Okay, enameled with some turpentine or something. So according to that, the formula is b dot dl is equal to mu0 I. I is known as here enclosed current. But I is equal to what? I into N. What is I? I is the current and N is the number of turns. Here, N is the total number of turns here. Here, capital N is number of turns. How many number of turns are there? And small n is number of turns per unit length. We say number density or number of turns per unit length. Cross multiply. Cross multiply, you get ln and then this will go away and b is equal to mu0 I. Next is what? Toroid. In toroid, what is happening? This is a toroid. And there is a wire wound in the form of a loop. Okay, so what will happen? There is a magnetic, so the wire is coming out and the wire is going in here. It's coming out and going in. So around it there is a magnetic field. So what is the formula now? B dot dl is equal to mu0 I. L is equal to 2 pi r, and mu0 n is what? 2 pi r into 2 pi r and into n into I. So this and this will go away. Why toroid is like that? Because then this is also a circle and the loops are also circle. This is also a circle and these loops are also circle. So for the two times you are writing 2 pi r, 2 pi r. So that will go away. So how did we get n is equal to n into L? N into, that is what? N into 2 pi r. Then substitute this value here, cut it, then we'll get this answer, mu0 Ni. So the formula for solenoid and toroid is same, mu0 Ni. Is that clear? Is that clear?
Yes, sir.
Yeah. So,
yes, sir.
okay. Now, next one is we will go with law, that is a parallel, that is. So we use the solenoids and toroids where in TV and radio, tape record and all. Okay, there we use this thing. Okay, clear? So force between two parallel currents and the ampere. Force between two parallel current and the ampere. This is also important question. Okay, clear with this, Dhruti?
Yes, sir.
Okay. Your practicals are starting from 18th, right? 18th or 15th?
Sir, 23rd.
23rd. We have enough time. Force between two parallel currents. Force between two parallel currents and the ampere. Two parallel currents and the ampere. Force between two parallel currents in the ampere. So now in this case, what happens? There are two wires. There are two wires like this. The two wires are carrying current, and the distance between the two wires, let it be A and let it be B. The distance between the two wires is L. Sorry, D. Sorry, D is the distance between the two wires. There are two wires like this. Okay, generally this usually happens in India. Like there will be overhead cables everywhere in India, electrical cables. Overhead cables mean poles will be there, on the poles wire will be hanging. They are said to be overhead poles, but in most of the developed countries you won't see this hanging wires and all. Okay, so you have underground cables everywhere. Even in India also, I think 1 or 2 cities are having this type of, like Chandigarh, I think in India, it has like underground cables and all. Some cities are there like that. Now, there are two cables A and B. Now current in this is IA, current in this is IA, and current in this is IB. IA and IB. And what is that? L is the length of the, here L is what? L is the length of the wire. Okay. And there is a magnetic field here. Okay. So the magnetic field here is what? BA. And here it is what? FBA. Force on B due to A. We have two forces. What happens around the first wire? There is a magnetic field like this. There is a magnetic field around the first wire, and also there is a magnetic field around the second wire also. Centered to this one. Centered to this one. There is a magnetic field around this wire. There is a magnetic field around this wire. Both the wires. So the magnetic field produced by the first wire is falling in, that is the second wire is falling under the magnetic field produced by the first wire, and the first wire falls under the magnetic field produced by the second wire. So they both are experiencing forces. Both the wires are experiencing forces. Okay, maybe repulsive force or attractive force. We will discuss about that. What type of forces. Now, so that we are only taking up to this length, not for the entire. We are confining ourselves to certain length. Now, what happens? The force that is the magnetic field of the first wire. So, what is generally, how do we write? F12 means what? AV means force on wire, force on A due to force on A due to B. Okay, force on A due to B. And FBA means what? Force on B due to A. Okay, force on B due to A. So now, so what is the formula here? BA is equal to what? Magnetic field of the first wire is what? Mu 0 into IA by mu 0 I by 2 pi D. Is it not? This is from the ampere circuit law. Mu 0 I by 2 pi R. Is it not? From ampere circuit law, first we studied about wire, right? This is the wire and this is the amperian loop. You remember this one? R is the formula. So B is equal to what? Mu 0 I by 2 pi R. Do you remember this one?
Yes, sir.
Yes, sir.
Yeah. So the same formula I applied here. Now, what is the formula what is the force on a current carrying conductor and is placed in the magnetic field? See, force on a current carrying conductor. Force on a current carrying conductor when placed in the presence of magnetic field. When placed in the presence of magnetic field is what? F is equal to what? F is equal to BIL sin theta, right? F is equal to BIL. Is it not? F is equal to BIL. So now
Yes.
what we are writing now? F is equal to, we are writing FBA. FBA is equal to what? Force on B due to A. So that is IBL into BA. Okay. So what is the formula now? IB is as it is. L is what? L is the length of the wire. Okay. Then we have BA. What is BA? Mu 0 into I into A divided by 2 pi D. So we will write in a proper order. Mu 0 IA IB L divided by 2 pi D. This is the formula for force on B due to A. The same formula will be there on the other one also. Okay. So force on A, FBA will be equal to what? Minus FAB. FBA is equal to minus FAB. Okay. So parallel currents attract and anti-parallel currents repel. So because there is a negative sign means that is they attract. So parallel currents attract and anti-parallel currents repel. Okay, parallel currents attract and anti-parallel currents repel. So now if you are writing about FBA, force on BD2A is given by what? FBA divided by L. Okay, FBA divided by L, which is given by what? Now L will go away, so we are left with what? FBA is equal to what? Mu 0 IA IB divided by 2 pi D. This is the formula for force per unit length. This FBA is nothing but force per unit length. Force per unit length for 1 meter or something. Then that is given by this formula. FBA or FAB, small FAB. So F is equal to, when we substitute 1 ampere here, how do we substitute? So when do we define it as 1 ampere? Here I will write the force. What is the force here? F is equal to 2 into 10 to the power of minus 7 Newton per meter. Small f. Force per small f is equal to this much. So how do we define 1 ampere now? 1 ampere means if 1 ampere. If he is asking define 1 ampere means don't write the definition 1 charge by 1 coulomb. 1 coulomb by 1 second. 1 ampere means if the force is this much, if the force between the two wires is this much, when separated by a distance of 1 meter, when the distance between the two wires, when the difference between the two wires is how much? 1 meter. 1 meter. If it is 1 meter, then the force experience is this much, then what do we say? It is known as 1 ampere. Clear? Is that clear?
Yes, sir.
This particular concept is used where in current balance in electricity department they use this. So that is how when you see high tension wires, maybe when you go the countryside, okay, you may be on the highways, you can see high tension towers. Have you seen that one? Carrying very high voltages, high tension towers.
Yes, sir.
So they are kept very far because this electricity department, they have calculated the magnetic field. How much will be the magnetic field of one over the other wire? So they keep lot of difference. Otherwise they can keep together, right? But if they are kept as much as possible, as far as possible, so that one wire will not fall into the magnetic field of the second wire. Okay. Otherwise there will be attraction, because if they are carrying this, if the two wires are carrying the current in the same direction, then they attract. So there can be shock again. So for that reason. So in India also, what will happen? Generally in the windy season or rainy season, what happens? These two wires stick together, and then what happens? They stuck together, and the fuse will blow off at the transformer. Now, that's why the electricity people, they keep a insulator between the two wires, like a say porcelain ceramic insulator, something like that, so that they won't come together. Okay. Clear? So copy this one. Then torque on a current loop and magnetic dipole. In that we are using a rectangular current loop. We can go for circular current loop, rectangular current loop, like that. So we are using a rectangular current loop. See, there are two magnets. Okay. Yeah. These are the two. See here. I cannot complete the diagram. Wait 1 second. North pole and south pole of the magnet. A rectangular coil is placed between the two poles of the magnet. Here, B is the width, A is the length and width. Now, here we are using two coils. Like this is the brushes, metal brushes, and this is the small cell, positive, negative. Now current is flowing in this way, and current goes to the brushes, metal brushes, and to the split ring commutator. This is said to be split ring commutator. Now A is the width, B is the length, and this is the axis. The dotted line is the axis on which this can rotate. Now current I is flowing in this way, here in this way, then current I is going in this way. Now, what is the magnetic field? This is the direction of the, B is the direction of the magnetic field. And what is tau? Here, tau is the torque and I is the current. Tau is the torque, I is the current. Is that clear? See once again, north, south, and this is the rectangular coil whose length is B, width is A. The dotted line is the axis on which it is rotating. The coil is rotating. This is a battery and brushes and split ring commutator. So we will take as A, B, C, and D. We'll take it as A, B, C, D. Now, this rectangular coil is placed between the two poles of the magnet. Now, the force. So what will happen? When the magnetic field is, when this is the current carrying conductor, around it there is a magnetic field. How is the magnetic field? See, you can apply Fleming left-hand principle for this. See, according to Fleming left-hand principle, what is that? Stretch the three fingers of the left hand in three perpendicular directions. If the forefinger shows the direction of the field, middle finger shows the direction of the magnetic field. Sorry, forefinger shows the direction of the field, magnetic field. Middle finger shows the direction of the current. The thumb indicates the resultant force. Now we will see. This is the magnetic field. Okay, and this is the current. See here. Okay, here. See here. This my middle finger is along the direction of the current, and this is the magnetic field. Forefinger is the magnetic field, and the thumb is going inside. Means if this is into the board. This one is into the board, and this is coming out of the board. Clear? This one is coming out, and this one is going in. If you apply the Fleming left-hand principle. So according to what is the force now experiencing F is equal to BIL center, because sin it here theta is 90 degrees. The angle between the current and the magnetic field is 90 degrees perpendicular. So the formula is what? BIL sin theta. So I can write here IBIL. Okay, BIB. L is what? Length is B. So force on the second one, this is F1. Force on the second arm is equal to, again, F is equal to BIB. So here F1 is equal to F2. The force is equal but in opposite direction. Now net force on the loop is 0. Clear? So there is a torque on the loop due to pair of forces. Okay. So here net force on the loop is 0. Okay. Net force on the loop is 0. Now, suppose here what will happen now? Now here what will happen? Here this is the magnetic F1, this is F1, this is F2, this is A by 2, this is also A by 2. And this is the magnetic moment. Small m is said to be the magnetic moment. Here also small m, I is the current, m is the, small m is the magnetic moment. Okay. So NIA, the formula for magnetic moment is NIA. Okay, that we will discuss that also. Now, what is the torque here? Torque is force into perpendicular distance. If you see carefully, torque is force into perpendicular distance. F into perpendicular distance is A by 2 plus F into perpendicular distance. Again A by 2. F into A by 2, F into A by 2. Or we can write F1, F2. So torque tau is equal to how much now? We can write F into A. Okay. So that will become what? B I into B into A. So that will become BIA. A is the area. A is equal to area. Area of the rectangle. Area of the rectangle is given by AB. Clear? Area of the rectangle is given by A into B. Is that clear with you?
Yes.
So here capital A is what? Capital A is said to be the area of the rectangle. Okay. Capital A is said to be the area of the rectangle. Now, and theta is the angle between the field and the normal. Here, theta is angle between the field and normal to the plane. Okay, field and normal to the plane. Okay, normal to the coil. Normal to the coil. So next one is what? The force on AB and BC and AD are equal again. BC and AD. Here, this one. The force here and here. They are exactly equal. Again opposite. But acts along the axis. That force is acting along the axis. So it won't contribute anything to the torque. It won't contribute anything. So we can simply write here what? tau is equal to what? If there are n number of terms, if suppose BIA is the formula, or we can also write tau is equal to what? Tau is equal to BIA sin theta, if you are writing. So we can write tau is equal to what? If there are n number of terms, if small capital N is the number of terms, if there are n number of terms, we can write tau is equal to what? NIAB sin theta. Okay, so suppose we can write here M cross B. Okay, what is M? M is equal to NIA. Okay, what is M again? M is magnetic moment. Okay, magnetic moment. M is said to be the magnetic moment. See once again. Now here, or we can also write tau is equal to, is similar like tau is equal to P cross E. So if you go to electricity thing, static electricity, P cross E, same formula. Okay. Now here see once again, there is a coil. There is a rectangular coil which is placed between the two poles of the magnet, north and south. The length is B, width is A, and this is the axis. This is a battery here, current is flowing through that one, and this is metal brushes. A, B, C, D is the rectangular coil. And tau is the torque, B is the magnetic field, and M is the magnetic moment. So Fn is equal to BIB, F2 is equal to also same. The two forces are same, but net force on that is 0 because there is no translatory motion. There is a rotatory motion. There is no translatory motion, only rotatory motion. So that is why the net force on the loop is 0, but there is a rotatory motion. So what is that? Tau is equal to force into perpendicular distance. We took tau is equal to BIAB, BIA. So A is the area of the rectangle, theta is the angle between the field and the normal to the coil. So tau is equal to BIA sin theta. N is number of turns, so NIAB sin theta. So tau is equal to N cross B. M is NIA. Okay, N is number of turns, I is the current, A is the area. Is that clear?
So can you explain it
Yes,
again?
sir.
Where? From where?
So the last, middle to last part.
See, tau is equal to what? Force into perpendicular distance. This is 2 times, right? When you
Yes,
write
sir.
here, this will become F into A. So what is F here? F is equal to BIB. BIB into A multiplied. Then AB is what? Area. Clear?
Yes, sir.
Now, if theta is involved here, exactly theta was 90 degrees. In this case, the first case, here theta is 90 degrees. So sin 90 is what? Sin 90 value is how much?
1.
1.
Yeah, sin 90 value is 1. So that is why we are not writing sin theta there. But if theta is involved, then we write sin theta. And if there are n number of terms here,
Okay.
instead of one term, if there are n number of terms, we add n there. But we wrote here because A cross B is AB sin theta, NIAB value is M. So in the place of this whole thing, we are writing small m. Clear? So suppose we are going to compare the electrostatics with magnetostatics. Okay, so one side I will write electrostatics formulas, and the other side I will write the formula of magnetostatics. Okay, magnetostatics or whatever it is. So we are right for axial line. See, we have axial line formula. What is that? BA is equal to what? Sorry, EA. For axial line it is 1 by 4 pi epsilon 0 into 2p by r cube. Here for magnetic field, BA will be equal to what? Mu 0 by 4 pi into 2m by x cube. This is the formula. For equatorial line, we write 1 by 4 pi epsilon 0 into minus p by r cube. But here it is equal to what? E axial is equal to 1 by 4 pi epsilon 0 into m by x r cube. This is the formula. Okay. Now, or m by x cube. This is the formula. Now, here we are writing 1 by epsilon 0. Here we are writing mu 0. Okay. So here it will be m. Here it will be p. Here it will be m. That is p is equal to what? 2 QA. And here m is equal to what? I into A, current into the area. I is equal to current into area. Here it is electric field capital E. Here